Hello guys and welcome to second day of 30 days of JavaScript, and today also we are going to look into a problem that is based on closures concept, second problem of the series, and the name of the problem is counter. Okay, so problem number 2620 and the name is counter. Let's read the question once. Given an integer n, return a counter function. Okay, let's stop and think about it. So given an integer n, so we are providing an input integer n to a function. Call it as an argument, or you can say it as a parameter. Both are different, but for sake, let's say we are giving some input to the function. This function return a counter function. Okay, this counter function initially returns n and then return one more than the previous value every subsequent time it is called. So now the outer function is returning an inner function, and inner function is first returning n, then n plus 1, n plus 2 every subsequent time it is called, right? So if you'll see example 1, input is equals to n, output is 10, 11, 12. So every time it is called, the outer function is calling the inner function. Inner function is first printing the value of n, then n plus 1, then n plus 2, something like that. So this is a perfect example of closure. How? For those who don't know what closure exactly is, let's look into it. So what is a closure? We have already looked it into the first video, but yeah, let's see. Closure in JavaScript happens when an inner function remember and can access variables from its outer scope even after outer function has finished executing. So, and that is why I called this is a perfect example of closures. See, here the outer function has the access to the variable n, right? But somehow inner function is also able to access it, not only access it, but also modify it. So first it is accessing, so it got the value, okay, this is 10, and then plus 1, 11, plus 2, plus 2, 12. So this is what happening over here. So first we got the value of 10 from the outer function, right? From the outer function. And then inner function was not only able to access it, but also modify it. So it modified to be 11, then it modified to be 12. So here we are not only accessing it, but we are also modifying the variable which is defined inside the outer function. This is outer function, this is my inner function, this is the variable which is defined over here. I am accessing it as well as I am modifying it. All right. So this is one thing. Now let's look into the solution. And before that, how closures is basically used here. So let's look into this. We need to make a counter function that start at some number n, okay, return the next number each time it is called. So see, initially the value of n will be set to how much? That will be 10, for example, right? And then it should be incremented to 11. Now the original value of n is not 10 but 11. Now again n plus 1, so it will give you 12. Again n plus 1, it will give you 30, and that's what is written. One more than the previous value every subsequent time it is called. So 1 more 11, 12, 12 one more 13, 13 one more 14, and every time it is called, it will modify the value of n, right? To do this, we define an outer function that takes n as input. So here if you see, that is already done. That is the boilerplate code that we are getting. Inside it, we define and return an inner function. So that is also done by them. So return function. We just need to write down the code for this return function, the inner one. Okay. That inner function remember the variable n thanks to closures and update it each time. So basically we don't have to do anything since we already know closure that the inner function will access the outer function value, right? So if I will simply write here return n plus plus, right? And that's done. Every time it will be called, so the value of n will be printed, and n plus 1, n plus 1, n plus 1, and it will keep on going, right? So let's run it. So input is 10. We are getting output as 10, 11, 12. Let's now submit it. Cool. So that's done. Now, if you want some explanation of the code, so let's look into that quickly. Create counter. We have the outer function that takes the starting number n. Here we have. Then return function, and this is gonna return n plus plus. This is the code that we have written, one line of code. Call returns the current value of n, then increment it to n plus plus, right? So every call that we are making, it first returns the current value of n. What is the current value of n? Initially it was 10. If 10 is the input, then 11, then 12. So that's what happening. Counter, when we are basically calling this function to execute, right? So when called multiple times, keep using and updating the same n stored in the closure. Alright. So this is one thing. Now there is an interesting thing, right? So basically here they are making, they're assigning this function to counter. If I do n plus 1, return n plus 1, what will be the output? Will it be correct or wrong? Do let me know in comments. From my point of view, I don't think that's correct. It's incorrect. Definitely it's incorrect. Why it is incorrect? Do let me know. Okay, if I'll run, I'll be getting 10, 11, 11, 11 something or 11, 11, 11 something. 11, 11, 11. And expected was 10, 11, 12. So why n plus plus is working and why n plus 1 is not working? So that's all. Do let me know why n plus 1 does not work in this case and we'll meet in the next video. Thanks.